All right, thanks for hanging in there. We're at number 13. We're almost there. It says if there are 10 cats and 8 dogs in the pound, what is the ratio of cats to the total? Ladies and gentlemen, I noticed on your test that a lot of you are not reading it all the way through. Please be very careful. This is an easy question. It says if there are 10 cats and 8 dogs in the pound, what is the ratio of cats to the total? Now, we know there are 10 cats. First of all, we know there are three ways to express a ratio, right? And we know there are 10 cats, and we know that the total is 18. So we can say it's 10 to 18, or we can say 10 over 18, or we can also say 10 to 18. But that's not just the answer, because more than likely the test is going to simplify it by the GCF. Now, we know the GCF of 10 and 18 can be 2, right? Well, let's find out. If we find the GCF of 10 and 18, all I'm going to do is the upside down cake method and think about a number that can be divided into 10 and 18 evenly. And I'm just going to start with 2. We know that 10 divided by 2 gives you 5, and 18 divided by 2 gives you 9. Now, the only other number in the world that can divide into 5 and 9 evenly is 1. So since 1 is the only other number, we stop there. If you want to, I can show you. But if we did 1, it's going to repeat itself, so it doesn't make sense. So if you end up with two numbers, you just multiply those two numbers together, and 2 times 1 is 2. So therefore, the GCF equals 2. So that means I'm going to simplify these numbers by 2, and I'm going to end up with 2, 5 to 9, or 5 over 9, or again 5 to 9. So it just depends. Now you can write your expression. I'm sorry, you can write your ratio any way you want, but just remember that on the test, the options they give you may be different. Okay, so just always look for one of these options and make sure you simplify them by the GCF. Okay. Number 14 says, what is an equivalent expression for 2 times 3x minus 11? You can do it however you want to, but I recommend that you apply the descriptive property in this instance here. And that means you're going to take this number 2 and you're going to multiply it by everything on the inside, and you're going to be done, right? So what is 2 times 3x? You know that 2 times 3 is 6, so we attach the x. And then we come over here and do 2 times negative 11. 2 times negative 11 is going to be negative 22. And therefore, you're done. That's an equivalent expression. Simple. Again, we are back to finding the greatest common factor of 12 and 36. You can do the upside down cake method, which one is the one that I enjoy. But if you have one that you like to do that's different, you can do whichever one you want as long as it works. So what's a number that can divide into 12 and 36 evenly? This time I'm going to start a little smaller so I can show you what to do if you end up with a bigger number. A lot of times, if you don't know what number can divide these things and both of them are even, start by dividing by 2. So we're going to do that. 12 divided by 2 gives you 6. And 36 divided by 2 gives you 18. Okay? But we know that these are two even numbers, so we can go some more. So I'm going to divide by 2 again. Okay? 6 divided by 2 is what? 3. And 18 divided by 2 is 9. Okay? Now, these numbers are not even, but we do know that 3 can go into 9. So because 3 can go into 9, we're going to divide both of these by 3. And 3 divided by 3 is 1, and 9 divided by 3 is 3. Now we are to that point again where there's no other number we can divide into 1 and 3 but 1, because 1 and 3 are both prime numbers. So we are done. So that means we're going to take these numbers on the outside, only the numbers on the outside, and multiply them together, right? So we have 2 times 2 times 3. 2 times 2 is going to give you 4 times 3, which is going to give you 12. So the GCF of these two numbers is 12. Very good. As I said, there are many different ways you can do. You can do prime factorization with the tree if you want. You can do the upside down cake method. Whichever way works for you, that is fine. All right, and last but not least, it says when the point negative 3 and 4 is reflected across the y-axis, where will where will the reflected point be located? What if the same point was reflected across the x-axis? So let's just do this. Reflection across y. And I'm going to draw a line and do reflection across x. I'm writing with my finger on the board, and therefore it's not picking up as good, but you can see it. All right, now, so whenever you are reflecting across any of the axes, first of all, we know that y runs up and down or vertically, and we know that x runs left to right or horizontally. Okay. Now, whenever you have a reflection across the y-axis, you're going to take your point and look at it. Now, you know that x comes first and y comes second. Whenever you're reflecting across the y-axis, your y-axis point stays the same. So your y value stays the same. So that's going to always stay 4. But our x value is going to change to its opposite, or its additive inverse. It's going to stay change to its opposite. So if it was -3 here, it's now going to become +3. Okay? And guess what? I know you know the answer to this one. If you did that with the y, you're going to do the same thing with the x. So we're going to write the point -3 and 4. This time we're reflecting across the x-axis. Well, if we're doing that, then what needs to stay the same? You're right, the -3. And what changes to its opposite? That's right, the 4. So that becomes -4. And guess what? You are done. Thank you for hanging in there. I wish you much success on your test. Please make sure you study. Also, I have not said this in the beginning of the video, but in the description box, you should be able to see a copy, an extra copy of the study guide that you can download and redo it yourself and come back to the video to check your answers. Ladies and gentlemen, this has been great. I look forward to working with you in the future, and I hope that you have an amazing day. Thank you. Talk to you later. Bye bye.